the thing is, change of base rule works for any base you can imagine. So if you're good with your exponents, here's one way you can think of this. I can change this. It's not just, change of base rule doesn't just work for log base 10 and natural logs. I can change this to log base 2 of 32 divided by log base 2 of 16. Why do you think I picked 2?
Because it's
easy.
Because it's about the only number I can think of that works, actually. Because 2, the answer to this, 2 to what power is 16? 2 times itself, how many times gets you 16?
4.
4.
So you can choose any number you want?
You can choose any number you want to, and without a calculator, that will sometimes be helpful. So this will be, the answer to this question, 2 to the what power is 16, is 4. The answer to the top question, 2 to the what power is 32, is 5. So that's 5/4, which is 1.25. And without a calculator, I now know that 16 to the 1.25 power equals 32. That answers this. This is the inverse way to write this one.
See, that makes sense. But when you put in a different number of E, the natural
Sure.
log, but that's a different number.
Yeah, you can't do natural logs without a calculator pretty much at all.
You know, I'll just ask you later.
Okay, I'm really curious what you're thinking of this one. Yes?
How do you get 4 of this from 5/4 instead of 1.25? I don't know if I want to do that.
Oh, okay. Let's show that step. Thank you for asking, because I'm sure you're not the only one. Okay, 5/4. Do you know how to make this? This is an improper fraction. Do you remember making this proper fractions?
You times it by 2.
Well, it's going to be 1
And 1/4.
and 1/4.
No, because I know you say, one more time, you do like, how many times is 4 going to 5? You say
Right.
1, so that's the big number.
Yep, and then the remainder 1.
Then do minus 4 from 5. Then keep the denominator.
It's been a while since I thought about it this way. You see, 4 goes into 5 one time with a remainder of 1, and then you keep the same denominator under your remainder.
So there's 5 seconds, it'd be 2 with 1/4.
It'd be, if it were 5, let's go over to this board for this one. If it were 5 halves, that would be 2 with a remainder of 1, and you use the same denominator, yes. And we can talk later about how to get from 1/4 to 0.25 if that's...
I understand.
Okay. Yeah, no, good. Ask those questions. So yeah, this is a fair non-calculator question. Let's do another one of those. See if I can make one up that won't blow up in my face. What do you think the log base 9 of 81 is? Now you're thinking 9 squared is, well, that's too easy. Let me do another one. Yes, it is 2 as a matter of fact. And I was about to prove that it's 2 through a long and complicated process. Pardon? Yeah, see, that's right. Very good. That's what I get when I make them up. All right, let's try this one. Log base 9 of 27.
3.
Oh, nope, that's 9 times 3. Okay, what,
1.5.
it's going to be somewhere around there, but we'll have to figure it out. Because 9 to the first is 9, and as Saul just reminded me,
1.5, I'm right.
9 squared is 81.
1.5.
Is it really?
Yeah.
That's embarrassing. Okay, let's find out. Nicely done. That is a very good guess then, Saul. All right, so now we've got, mind if I work it out, though, without a calculator? Thank you. Now I'm going to, what base will I choose to change this to? What base would make sense with 9 and 27? 9 and 27 are both powers of 3. Okay, so I'm going to make this log base 3 of 27 over log base 3 of 9. 3 to what power is 27?
3.
And then one's 2.
Yep, and then 2, 1.5 with no calculator. Whew, okay, there's a fair amount of that. Let me check one more thing here. That we didn't go over as much that your book does some of. We should just do that one. So that's... Okay, you know what, I'll come back to that one. Maybe that example at the end. Okay. We don't really go into that. Okay. Now. Your book's doing something with a couple of problems on the homework tonight that involves a rule that your book hasn't taught you yet. I think they're doing it a different way.
Why don't we just connect to those problems?
That's a thought.
That makes no sense.
Well, I'm going to go to the graphs and then I'll come back to that one. All right. Okay. Now, basic graphs. Okay. Basic logarithm graphs. Remember, they are inverted exponential graphs. Do this by hand. Inverted exponential graphs. Okay. What does y equals 2 to the x look like? Cody.
Wouldn't it be
X equals 2 to the y?
Oh, let's think of the original one. What does y equals 2 to the x actual look like? You're already inverting it. No, this is an exponential growth. Y equals 2 raised to the x. Saul and Worst are doing interpretive dance, which
so
are
increase
accurate.
to
It's going to increase.
more.
What are my three interesting points going to be?
-1, 0, and 1.
Negative 1, 0, and 1 will be my x values. What will be my y values?
1/2, 1, and 2.
Yep. So this is going to go here. What will my asymptote be?
0.
the x-axis.
X-axis, y equals 0. The line, y equals 0, which is the same thing as the x-axis. So that's going to be, boom, that's my 1/2. Here's my 1. Here's my 1, 2. Got a squeaky marker. Now I need another color. Okay, what will be the graph of inverse of this? James started to say the inverse of this a second ago would be x equals 2 to the y.
Well, now you just flip them around and it's like 1/2 and...
Right, then you solve for y, but we don't really have a way to solve for y here. So you can flip these points.
Yeah.
How do we write this with logarithms? The inverse of y equals 2 to the x, the same thing as x equals 2 to the y.
So log y base y 2.
Y equals log base 2 of x.
Wait for...
This will be the inverse.
2y.
Yeah. This will be the inverse. Okay? And the interesting points on this one are going to be 1/2, -1, okay, 1, 0, 2, 1, and the asymptote is going to be what line? It was y equals 0 on the original. If inversing is always switching all of the x's and y's, what would the asymptote be? X equals 0. If
Wait.
y equals 0 is the x-axis, Saul, what's x equals 0? The y-axis. Very good, Dean.
Mr. Belva, how
Yes.
does that equal y equals 2x? When doesn't that mean 2 to
This
the
doesn't
what?
equal y equals 2x.
2 to the what power?
Yeah, 2 to the what power equals x. That's this statement. These are the same statements up here.
Oh, okay, got it.
Yeah, these two in blue are the exact same statements, and they're both inverses of this. This is a fairly obvious inverse of this. This is what logarithms are designed to be a way to rewrite this. And tomorrow I'll show you directly how to go from here to here. Okay?
So now